Hello everybody, welcome back to Anantha Lakshmi Academy. I am Anantha Lakshmi. If you are visiting my channel for the first time, please do subscribe to Anantha Lakshmi Academy so that you will get to know whenever I upload the next video on the same. Alright, today we are going to discuss a few important concepts which are needed for us to solve exercise 7.3 problems. The first one includes the area of the triangle given the vertices, the points. Okay, let us get through it first. What is the area of triangle? How do we figure out the area of triangle? Whatever the formula which we have learned is like, say for suppose I have a triangle wherein this is 6, 0 and this is a point on y-axis, right? So x coordinate will be 0. Okay, now I form a triangle. Alright, the angle between the axes is right angle. Now if I ask you to figure out the area of the triangle, how do we do that? The base, this distance is nothing but 6 and this distance is nothing but 4, isn't it? That's what we have discussed in our earlier videos. If you are not able to understand this, please go through the introduction part of coordinate geometry, the very first part, right? Wherein we have explained in detail, that is. So what is the area of the triangle? Which is equal to half into base into height. What is the base here? 6 and height is 4. 2 3s are 6. The answer is 12, isn't it? So now that is the triangle when coordinates, not the coordinates, when you know the base and height. Now that a point lies on x-axis and other point lies on the y-axis and one of the point is origin. So it was quite easy for us. Yes. Now these are the coordinate axes. This is x-axis, y-axis, origin. Now I have a triangle like this. Point A, point B and point C. Okay. And point C. A, B and C. Okay, let me join all these things. Now, where is this triangle? This is in the coordinate plane. Now, for A, the coordinates are x1, y1. For B, the coordinates are x2, y2. And for C, the coordinates are x3, y3. Now, if we are asked to figure out the area of the triangle when the vertices in the coordinate plane are given, how do we do that? Okay, let's try figuring that out. Let me draw a perpendicular from A and name this as P. From B, Q, and from C, we have R. Okay, now I have drawn perpendiculars from each vertex to the x-axis. Now look at the shape of ABQP. ABQP. Isn't it resembling the trapezium? Right? And look at the shape of this thing. ACRP. This is also a trapezium. And BCQ or also forms a trapezium, isn't it? So let me tell you. So for us, ABC are known, where A is equal to x1, y1, B is equal to x2, y2, and C is equal to x3, y3. Now we have drawn perpendiculars from What are the perpendiculars respectively? AP, BQ and CR respectively. That's what we have drawn now. Now AB, QP, AC, RP, BC, QR forms trapezium. What is the plural for this? Trapezia. Plural form of trapeziums is trapezia. As we have 3 trapeziums, I just wrote it as trapezia. Now look at this. If I want to figure out the triangle area ABC, what if I do this trapezium's area plus this trapezium area minus the downward, the third trapezium area. That's what gives us the area of triangle, isn't it? Look at this carefully. I just want to know the area of this part, wherein I can solve this trapezium's area, and subtract this part from that. That will give me the triangle, right? So, area of trapezium is equal to, what is the formula? Half into sum of parallel sides, whichever are parallel. Okay. So, area of triangle, what does, so even before that, let us figure out the distances. What is OQ? This is the distance on x-axis from origin. What is its coordinate x2, right? As this is perpendicular to this distance also becomes x2. Okay, now what happens to P likewise? This is going to be x1 and this is going to be x3. Alright, likewise this distance is y2 and this total distance is y1 and this distance is y3. Alright, this total distance. Okay, this and all, if you are not able to understand, that is also well explained in the part 1 of coordinate geometry. Please go through it. So the area of trapezium is equal to half into sum of the parallel sides multiplied by distance between the parallel sides. Distance between the parallel sides. The area of trapezium is equal to half into sum of the parallel sides multiplied with the distance between the parallel sides. So let us try figuring out the area of triangle ABC. So that becomes half into the first trapezium ABQP. Parallel sides are BQ plus AP multiplied with distance PQ plus half into the other one is AP plus CR multiplied by the distance PR minus half into the lower one, the lower trapezium, which is nothing but BQ plus CR multiplied with the distance, total distance is RQ. Alright, now how do we do this in the whole term? Even before this, here let us figure out the distances, like what is BQ, what is AP. Let us try writing it next to the diagram so that will be easy for us. What is BQ? BQ is nothing but Y2. Alright, AP, what is AP? AP is Y1. Next PQ. PQ is nothing but OP minus OQ. OP minus OQ is equal to x1 minus x2. x1 minus x2. Next, AP is, we have known CR. CR is y3. Next, PR is nothing but OR minus OP, which is nothing but OR minus OP. OP is x1, OR is x3. So this is going to be x3 minus x1. Next, BQ we have already written, CR we have already written. RQ is something which we haven't written. RQ is nothing but OR minus OQ, that is x3 minus x2. Okay, now let us replace the values in the formula. So in all the three terms, half is common, so I am just taking that out. So this is minus y2 plus y3 into x3 minus x2. So upon multiplication, this becomes, multiply the first term with the second term and make sure the x stands in the front. So that way it becomes x1 y2 minus x2 y2 plus x1 y1 minus x2 y1 plus x3 y1 minus x1 y1 plus x3 y3 minus x1 y3. Now for the last term there is a negative sign. Okay, don't forget that. Minus, I am just multiplying it with minus so that minus x3 y2 plus x2 y2 minus x3 y3 plus x2 y3. Alright, I just multiplied the minus also in the same way. Now look at the negative term. First negative term x2 y2. Is there a positive x2 y2? Yes. That's get cancelled. Next, minus x2 y1 we have. Is there a positive term for that? x2 y1. No. Okay, leave it. Minus x1 y1. Is there a positive term for that? No. Okay. Next, minus x1 y1 and plus x1 y1 gets cancelled. Likewise, plus x3 y3 and minus x3 y3 gets cancelled. So what is remaining for us? Half into, I'm writing all the x1 terms aside. So that becomes x1 y2 minus x1 y3. Two terms finished. Now we have x2 term is there? Yes. Plus x2 y3 minus x2 y1 plus x3 terms. How many x3 terms we have? x3 y1 minus x3 y2. Okay. Plus x3 y1. Yeah. That's all we have. How many terms? 1, 2, 3, 4, 5, 6 terms we have, and we have written them. Alright. Now, what happens to this? Half into, take x1 common in the first two terms. x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. So, this is going to be the formula for us when we are asked to figure out the area of a triangle given the vertices. How did we solve that? We just took a triangle in the coordinate plane and we drew the perpendiculars. Later we figured out that it is the combination of two trapeziums minus the lower trapezium. So what did we do? We just took the area of the trapezium. In order to figure out the area of a triangle, we just did it as sum of the two trapeziums, the above ones minus the below trapezium. That is what we have done, and we ended up a formula wherein it is not so difficult to remember this. x1, when it is x1 term, the y terms are rest of the terms, y2, y3, not y1, okay, plus x2 into whatever we have missed, y3, y1, plus x3 into y1 minus y2. So this is going to be the area of triangle when vertices are given. Alright, now we have one more formula, which is Herons Formula. Herons Formula for area of triangle, wherein if you have a triangle A, B, C, whose lengths are A, B, C, that formula is going to be area of triangle ABC. You just don't have to simplify this. You just remember this formula as S into S minus A, S minus B and S minus C, where what is S? Sum of the lengths divided by 2. So here the Herons formula for the area of triangle is S into S minus A, S minus B, S minus C, where S being sum of all the three sides or all the three lengths divided by 2. And this logic I have explained you in one of the trigonometric videos, wherein the vertex, whatever is the capital letter, the opposite side will have the small letter length. And for B, the small b will be opposite, and for C, the small c will be opposite. Initially, it will be like small a is equal to BC, small b is equal to AC, small c is equal to AB. This we have to remember. By now, you will be knowing. So, that is about area of the triangle. And there is one more condition, which is collinearity. Collinearity, which we have already discussed. And during solving exercise 7.1 problems, I have told you that when the points, 3 points A, B, C lie on a single line, then they are said to be collinear. When the points are collinear, you cannot form a triangle. There were questions like, can you form triangle with the following points is what is given, wherein we said the AB plus BC is equal to AC. So the points are collinear, they are on a straight line, hence triangle cannot be formed. Now you will have different type of questions wherein they will be asking if the area of the triangle is 0 or if the points are collinear, figure out one of the variables. That is the way they will be asking. So for collinearity, when the points are collinear, remember, always remember, area of triangle is equal to 0 because you cannot form a triangle with collinear points. Hence, area of the triangle for collinear points is 0. Alright, so that is about the collinearity. There is one more simple concept which is slope of a line. I'll be covering the same in this video itself so that the concepts that are needed for us to solve exercise 7.3 and 7.4 will be done. Alright, so let us discuss the concept of slope of a line. Again, the same coordinate axis and a line in the coordinate plane. Alright, x1, y1 and x2, y2. So slope of a line is given as, is denoted by small m by change in y by change in x. What are these changes? From here by moving from the point A to B, there is some change. Now the distance is increased, right? There is some change. What is that change? That is nothing but from y1 it has gone to y2. So y2 is greater. y2 minus y1 by x2 minus x1. Alright. So if we draw a perpendicular here, this forms a triangle wherein this is going to be a right angle. Slope is also denoted as tan theta. Tan theta is nothing but opposite by adjacent, which is also equal to, see here, this is going to be, this is y2, right? This coordinate also is going to be y2 and this coordinate is going to be y1 as usual. So the change will be y2 minus y1 by x2 minus x1. Locate this point. If you are to locate this point, since this is on the same line, this x coordinate is going to be x1 and as this is perpendicular drawn from B, y coordinate will be y2. That is nothing but y2 minus y1 by x2 minus x1. On this formula, we have problems based on exercise 7.4 based on this formula. All the problems are based on this simple formula. Alright, now that we are done with the concepts that are needed for us to solve exercise 7.3 and 7.4, it is time for us to go through examples. As I will be mentioning in all my videos, please go through the examples so that you will have an idea on how to solve the problems. Alright, if you like the content, please do like, share and subscribe to Anantha Lakshmi Academy. Later in the videos, I will be solving the exercise problems. Till then, keep watching Anantha Lakshmi Academy. Thank you.